Hey everybody, this is Alex Merced from alexmercedcoder.com, and continuing on in our adventure of looking at pretty much every function in Lodash, which has been quite a journey. I think we're like 3 or 4 hours into this. Um, okay, so now we're going to be looking at these objects. But see, we're almost there. We're getting there. Okay, so we're going to be looking at the object functions in Lodash, and let's just start working with assign. Okay, so assigns own enumerable string key properties of source objects to destination object. Source object are applied from left to right. Subsequent sources override property assignments of previous sources. So basically, it just seems like you're just giving one object to another object. So let's see here. Assign A to new foo, new bar. Function bar. Function foo. This dot A. This dot C. Let's see here. Foo dot prototype B. Okay, so this is a kind of a interesting example. So basically, using a function who just assigns a value to itself of 1, because functions are objects or functions are in themselves a method of an object that they are part of. Okay, so let's go back to our, here we go, Lodash. And we were looking at this object one, assign. So basically, again, we're assigning this value of 1 to a property called A on function foo, because again, the function in itself is always going to be the property of some object. So there's an object called foo. C, we're going to assign a value called C to bar. And we're going to say foo prototype is going to be B equals 2, because it's the prototype of B, so it's the object that it's pulling from. And bar.prototype.d is 4, so each of these have 2 properties. And now let's see here, assign A to a new foo, new bar. So it's creating a new object of prototype foo and a new object of prototype bar. Assign A 0. So since assigning this object, so it's taking this object and assigning the new prototype. And it's going to get these 2 properties because these are in the function. So the function actually technically constructs these. These were assigned after the fact, so they're not inherently part of the prototype. Okay, let me see here. Enumerable string key properties of source objects to the destination are applied from left to right. Subsequent sources override property assignments of previous sources, because it's going to take that function. Okay, that's interesting. I don't see the need for this. I mean, again, this might have existed before classes existed, when the prototype, directly working with prototypes was more of a thing. And just this method of sort of defining prototypes is also fairly foreign to me. I've never worked with it that way. That's interesting. Okay, but I get it. It's creating, it is assigning this property to its prototype, and then the prototype will be under the label of foo. This method is like Simon, except it iterates over our own inherited source properties. So in this case, it would have all the properties, not just the initial properties, but all the properties. Okay, assign in with function customizer. So this is basically going to be the same thing with assign, except you have a customizer that's going to customize how the values get assigned. Return is undefined. Okay, not going to even touch that one with the. I'm gonna move on from these assigns. It just gets sort of into nit and grit JavaScript prototypes that I really don't want to get into right now, because I'll spend literally like half an hour just on walking through that. I might have to just do a separate video on that. Okay, creates an array of values corresponding to paths of object. So let's see here. an array of values. So in this case, here's value 1. A equals this array, or this array with an objects. Okay. So in this case, let's just give this one we'll just try out. So dot at. So it's going to create an array of those values. String the property path to pick. So a 0, which would be this, and then it would be property b dot c a1. Okay, so basically you can sit there and say, hey, grab these particular values in this order and create an array of those values. So you can see here it's first it's grabbing the 3 because that's the path to the 3, and then this is the path to the 4, so it grabs the 4. That could be useful. It'd be a very unique situation where I'd find myself using that, but I could see a potential, like if you have like a bunch of related values that are deeply nested within an object. Creates an object that inherits from the prototype object. If a property's properties object is given, its own enumerable string keyed properties are assigned to the created object. So basically, it's going to create a new object, and then you can add other properties with a second argument. Okay, so let's give that one a shot. Okay. Dot create. So we're gonna create it based on, we're gonna use my obj as the prototype. So it's gonna inherit all of my obj's properties, and then we're going to also include another object with another property that's not already inside the prototype, which will be email, which will be Alex at alexmerced.dev. Okay. So then we should get an object that has all these properties and this property. It might just have this property and be able to refer to those properties. We'll see. Let's run it. Yep. Okay, that's what I thought. Okay. So basically, this is the object's property, but it has my object as the prototype. So what I can do, just to kind of illustrate that it does do that. So even though you don't see name, age, location, favorite band, what I can do is I can console log. Well, I didn't actually save this object anywhere, so I won't do that. So what I can do is at the very end chain dot name. Okay, so it'll look for the property on this object that was created, look for a name property. It won't find one, so it'll check its prototype, my object, and find Alex. So if I am correct, this should print Alex on the screen, and that's what it does. Okay. Again, that gets into the whole idea of prototypes. Looks like a lot of this is getting into the idea of prototypes, which I do have a video on prototypes. I recommend you watch that just because it's tricky. Basically, the idea is that every object can have a prototype, and if it doesn't find that property on that object, it'll go look at its prototype. So since this object, as you can see, doesn't have a name property, we take a look at the object we set at its prototype, so it goes over there and looks at that. And if it doesn't find it there, it'll look to see if my obj has a prototype, and then keep looking, and you create this big prototype chain. But it's a very tricky concept to fully wrap your head around. So let's go back to Lodash. Okay, defaults. Assign, own, and inherited enumerable string key properties of source objects to the destination. Okay, I'm just going to look at the example. Defaults. A1, B1, C1. It returns an object. 3. So arguments, the destination object. Okay, so this is the destination object. The default, and then this is sources object, the source objects. Okay, and in this case, these would be defaults, so it would have to have these properties. But since an A property was already defined inside of it, it doesn't take the default of 3. But since a B property was not defined, it does assign it the property of B. That's okay. I mean, I could see how you could use that to do object-oriented programming before classes were included in JavaScript. But there are other ways to kind of do the same thing. But that's what it does. It basically says, here's your first object. We're going to create this. We're going to make a new, return a new object of this. And then we're going to compare it to these other default objects to see if it has all the properties that these objects have. And if not, use those default values. Okay, and I think this just goes deeper, so you can go into much more deeper nested objects and get the same effect. Find key. This method is like find, except it returns the key of the first element predicate that returns truthy instead of, so it's like find, except instead of finding an index, you're finding a key. So it finds a key with that value. That's fine. I'm not going to go over that. For in, iterates over an inherited enumerable string, key properties, invokes iterate each for you. So this is just a for in loop. Okay. So yeah, so we're iterating over this object and then creating a callback function, and that takes the value and the key. Okay. It's a for in loop. And then again, for in write would mean starting from the back end. That's self-explanatory. For own iterates over own enumerable string key properties of an object and invokes iterates for each property. The iteratee is invoked with 3 arguments: value, key, and object. The iteratee functions may exit iteration early by explicitly returning false. Okay, so it's just another for loop. Okay, for own new foo. Function invoked per iteration. Returns an object. Okay, and again, it's not when you're iterating over an object, the order is never guaranteed. An object invokes iteratee for each property, value, key. Yeah, it's just a for in loop that you can have end early by returning false. Interesting. This method is like for own, except that it iterates over properties of object in the opposite order. So yeah, it's from for own right, so it starts from the opposite end. Functions creates an array of function property names from own enumerable properties of objects. So it takes all the functions. So let's see here. This function foo, this dot a equals constant a. So since both of these are functions, there's a function property called a and a function property called b, because we're assigning a function to these variables. Okie dokie. And doesn't happen here. Okay. Functions creates an array of function property names from own inherited enumerable properties. So basically, in this one, you're only getting the original constructed property, so A and B. In this one, you should be getting all of them. So using the same example, you get A, B, and C. So these are really complicated object stuff. Most of it which isn't as necessary anymore with the inclusion of classes. But okay. Gets the value at path of object. If the resolved value is undefined, the default value is returned in its place. Gets the value at path of object. If the resolved value is undefined, the default value is returned in its place. That could be useful. I can see how that would be useful in dealing with like objects where you're not sure if the value exists or it's undefined value without throwing a runtime error. Although there's ways to deal with that using, the OR operator. In future we'll have chain the nullish coalescence operator that'll make life a lot easier. Or no, the optional chaining operator. You'll be able to put like a question mark when you're grabbing different object properties. I cannot wait for that to be implemented. That's going to make my life much easier. Okay. Object. The object to query. What's this one? It says gets the value at path of object if it is resolved. Oh, this we were just talking about. So basically here we're saying get this property from this object. It's A, B, C. Okay, and if there's nothing there, the default is default. So let's see here. A property inside A, well, A is an array, so there is nothing there. So you're going to get default. Because even though there's a B property, it's not within the A property. There's an array first, so you'd have to call like 0. So here's A, 0, B, and B we have C, so that should be 3. So you don't need a default value. Here it's A0 dot B dot C, which should also get you 3. Okay, it checks if the path is a direct property of object. So it just checks to see if the property, if that path is in the object. So object does it have A, B? So let's see, does it have A, B? Yes. There is an A property with a B property inside of it. So this should be true. Okay, other, this object here, does it have an A property? It does, but still returns false. Look at this carefully. It's an object called other. Oh no, other. Oh yeah, it's going to create an object. But inside A, we're creating another object with B. Not quite sure I understand why that's false. We're hitting gray areas in my knowledge set. Amazing, which just means I have to learn more, which is always good. I like learning more. Okay, checks if the path is a direct or inherited property of the object. Okay, this is all kind of just checking whether the object has a thing. Invert creates an object composed of the inverted keys and values of the object. So basically all the values become keys and the keys become values. So I can, yeah, that's what I thought it would do. That's okay. Invert by. Okay, yeah, so most of these are very, very niche functions. So let's see, it invokes a method at the path of the object. Okay, so it's basically going to call a method with certain arguments. Slice 1, 3. Again, not quite sure why I would use that. It creates an array of, and again, some of these things, like you take a look at the version, actually this is a fairly more recent addition. Still not quite sure why I'd use it. See, goes way back. 0.1. Creates an array of the owner numeral property names of, and that's built into JavaScript now. You have the keys function as and objects. Creates an array of the own and inherited numerable property names. So this would also get the ones of the prototype. So ABC. Map keys. Okay, I think we're kind of getting past all the. This method is like assign, except that it recursively merges own and inherited numeral string key properties of source objects into the destination object. Source properties that resolve undefined are skipped if a destination value exists, so it just merges two objects. Object other, and turns into one object. Oh, omit, this we've used. The opposite of pick. Basically, the idea here is you're saying create a new object based on this object, but don't include this property. So in this case, you have an object with A, B, and C, and you want to create a new object, but you want to exclude A and C, so now you have an object with just B. That's useful. There's a way of kind of doing the same thing with a spread operator, which is what I typically do nowadays. So I don't have as much of a need for that anymore. Which you can find in my spread operator, or I think is in my objects masterclass video. I go into that, and I go into prototypes there too. Pick is just the opposite. You're saying I only want these properties, nothing else. Okay, set the value of the path of object. It's a portion, path doesn't exist, it's created. So set object 4. Okay, I'm not even 2 pairs. We kind of talked about this in a previous video. So this kind of creates that array of little arrays that are key value pairs. So that's actually, I think, in the first video in this series. So I'm going to let that go since we talked about it already. Transform, an alternative to reduce. This method transform an object to a new accumulator. So what is this, like reduce for objects? So let's take a look. Okay. Transform 2, 3, 4 function. So this is the array that's being transformed. And then here is the result, n. Okay, which is going to be the value. So result dot push n times equals n. So in that case, 2 plus 2 times 2 is 4. Return n modulus 2 equals 0. Okay. And then 4, 9. So let me think about this. So this would be, so 3 times 3 would be 9. 9 modulus 2 would be, let's think about this. Iterative functions may exit iteration explicitly by, oh, okay, I see. So since in this case, this is the first time it, okay, so basically it'll stop if it ever iterates over a non-even number. So the first time it does 2 times 2 and pushes it to the result array. This property here. Then, so basically this is just an empty array they use to accumulate values. Then in the next iteration, 3 times 3 is 9, gets pushed into the array, but since 9 is not an even number, it returns false, ending the, and then we know that result is a empty array because it's mentioned right there. So it literally is just reduce, except a reduce that can be ended early. So you can make a situation where it returns false and says stop iterating. Removes the property at path of object. Okay, so you're just removing things. Update, except that updater produced. Okay, these are not interesting ones. Values, that's just object.values now. And what are this? Sec methods. So let's go down here. I think I'm gonna, most of this stuff looks like it's stuff that is in JavaScript now, like all this stuff, trim end, truncate. So I think at this point I'm gonna wrap up this series. There's more stuff on Lodash. Lodash is and it's ever growing, and there's a lot of really useful stuff that we saw across these videos, mostly with like arrays and iterating. But now we're getting into some stuff that doesn't seem like it's adding as much value as the stuff that we've gone over already. So I'm gonna kind of call it a day. So hopefully you guys enjoyed this Lodash series, got you more interested in this library and wanted to try out this library. Again, it is a big library, so think about that, the cost of using it as far as your bundle size. But then again, you have options like tree shaking, which you can do with things like rollup, I think Webpack, which will allow you to only pay for the functions you're using instead of having to have the whole library part as your bundle. So have a good day.